Have you ever noticed that everything in the universe is in motion, spinning? From galaxies and stars to planets and even the tiniest particles, rotation is a fundamental feature of the cosmos. But why? Why does everything spin? The answer lies deep within the laws of physics and the way our universe has evolved since the Big Bang. The story of spin in the universe begins with the aftermath of the Big Bang. In the early universe, gas, dust, and energy were spread out, but as gravity began pulling these materials together to form stars, planets, and galaxies, small random motions became magnified. These tiny movements gave birth to rotation, and as matter clumped together, the spin accelerated. This happens because of a fundamental law of physics called the conservation of angular momentum. Once something starts spinning, it keeps spinning unless an external force slows it down. As cosmic objects like stars and planets formed, they inherited this rotational motion. A collapsing cloud of gas, for example, spins faster and faster as it shrinks in size, much like an ice skater pulling in their arms to spin faster. This is why most celestial bodies, from planets to galaxies, rotate. Spin not only plays a role in the formation of these objects, but also in maintaining their stability over time. Without this initial rotation, the universe would look very different. The spin of planets and stars originates from their formation process. As clouds of gas and dust collapse under gravity, they start to spin faster due to the conservation of angular momentum. This is the same principle that makes an ice skater spin faster when they pull their arms in. The collapsing cloud transfers this rotational motion to the newly forming celestial bodies. This spin also causes planets and stars to bulge at the equator due to centrifugal force, making them oblate rather than perfect spheres. For example, Earth is slightly flattened at the poles and bulges at the equator because of its rotation. Moreover, spinning provides stability to these celestial bodies, helping them maintain their structure and orbits over long periods. Spin is a fundamental aspect of the universe, ensuring that objects formed from collapsing clouds of gas continue to rotate. Galaxies also exhibit rotation, but their dynamics are more complex than those of individual stars or planets. Billions of stars orbit a central point, often a supermassive black hole, at varying speeds based on their distance from the center. Observations of galaxy rotation curves revealed that stars farther from the center move faster than expected, leading to the discovery of dark matter, an unseen mass that contributes to a galaxy's gravitational pull. Additionally, supermassive black holes influence the rotation and behavior of surrounding stars and gas. Overall, galactic rotation plays a crucial role in the structure and dynamics of the universe, shedding light on the presence of dark matter and the influence of black holes. At the quantum level, particles such as electrons possess a property known as spin, which is not a physical rotation, but an intrinsic form of angular momentum. Quantum spin affects how particles interact and combine, playing a crucial role in the structure of matter. For instance, electrons have a spin of 1/2, which contributes to their magnetic properties and governs their behavior under the Pauli exclusion principle. This principle states that no two fermions can occupy the same quantum state simultaneously, leading to the formation of distinct electron shells around atomic nuclei. Thus, while quantum spin differs from traditional rotation, it is essential for understanding the fundamental behaviors of particles and the structure of the universe. While the conservation of angular momentum keeps objects spinning, external forces can gradually slow down their rotation over time. One of the most significant forces that cause this is tidal forces, gravitational interactions between two celestial bodies, such as a planet and its moon or a star and its planets. A prime example of this is Earth and the Moon. The gravitational pull between them causes tidal bulges on both bodies. As Earth rotates, these tidal bulges are dragged slightly ahead of the line, connecting the centers of the Earth and Moon, creating a torque that slowly transfers Earth's rotational energy to the Moon. This process has led to the gradual slowing of Earth's spin, increasing the length of our days over millions of years. At the same time, the Moon is moving slowly away from Earth as it gains angular momentum. This phenomenon is known as tidal locking, where the rotational period of one body becomes synchronized with its orbital period around another body. This is why the Moon always shows the same face to Earth. Its rotation period matches its orbit around our planet. Many moons in the solar system, like those of Jupiter and Saturn, are also tidally locked to their parent planets. Tidal forces aren't limited to moons and planets. They also affect stars and can slow down the spin of stars over time if they have close companions, such as binary star systems. Even in the broader context of galaxies, tidal forces between neighboring galaxies can distort and slow their rotations, creating tidal tails and other cosmic structures. While spin may be a natural and persistent feature of the universe, these tidal interactions demonstrate that the rotation of celestial bodies can change over time, often on a cosmic timescale. Spin may slow, but it rarely comes to a complete stop, maintaining its role in the grand motion of the universe. The rotation of planets, especially Earth's spin, plays a crucial role in making life as we know it possible. One of the most significant effects of planetary spin is the creation of the day-night cycle. Earth's 24-hour rotation gives us alternating periods of light and darkness, which are essential for regulating temperatures and maintaining a stable climate. Without rotation, one side of the planet would be in constant daylight, while the other would experience perpetual darkness, leading to extreme heat on one side and freezing cold on the other. These harsh conditions would make it difficult for life to thrive. The magnetic field shields us from harmful solar radiation and cosmic rays, preventing them from stripping away our atmosphere and protecting life on the surface. Spinning also stabilizes planetary climates. The rotation of both Earth and the Moon contributes to this balance. Without a stable rotational axis, Earth's climate could fluctuate wildly, making it much harder for life to adapt and survive. From the cosmic scale of galaxies to the smallest particles, spin is a fundamental characteristic of the universe. Spin provides stability, creates the conditions necessary for life, and even shapes the structure of galaxies. As we look out into the universe and observe this cosmic dance of spinning celestial bodies, it's clear that rotation isn't just a consequence of the universe's laws, it's a driving force that has shaped the cosmos and made life on Earth possible. The next time you observe the sky, remember that everything is part of the universe.